Thank you. So, yeah, this is a long talk article that appeared back in June. So I will try to summarize the main findings of this article. So this is actually an article that is not about virtual reality, but of course, gesture elicitation studies have been used. The method, the very generic method, has been used for many domains, including virtual reality, as you see here. So the goal always is to design gestures that are self-explainable or easy to learn. Here, actually, this is one of the very influential papers in the domain back in 2009 by Walbrook, Morris, and Wilson. And they describe the gesture elicitation study as a process where participants are prompted with a reference or the actions or effects of actions, and they perform gestures that cause these actions that we call signs, we call here. So the main challenge here is to come up with some mappings between signs and reference that gather, that reflect a high consensus, the high consensus of participants. And to this end, actually, agreement analysis is very important for these kinds of studies. Now, to analyze agreement, before going to agreement, let's see what we mean by agreement. So in this particular example of a study, we have study participants, and let's assume that participants are presented with a referent for a 3D environment to rotate an object from A to B. And independently, the participants here, the two participants, propose some gestures. So here you see that even if these two different gesture proposals are slightly different, for example, you see a grasp gesture in the second, the researchers may decide that this actually reflect, they may classify it into the same sign, and then this is how we say that there is an agreement. So the more the agreements, the higher is the evidence that there is consensus over gestures, right? The more agreements overall in the study. Now, there are there is a lot of research on how to quantify an agreement. This is 3 articles, is the most representative articles in the literature. So in 2005, Walbrook and colleagues introduced the agreement index that we call here A. Then this index has been used by hundreds of user studies. 10 years later, Vatov and Walbrook advocated for the use of an improved index, that it's the agreement rate index that we write AER. They also introduced a significant test, the VRD test for comparing agreement with team participants, but also some guidelines for how to interpret agreement scores, what agreement scores are, and what is agreement high or low. Now, 1 year later, the same authors introduced the VB test for comparing agreement between dependent participant groups. Now, so the article actually argues that actually agreement analysis is very important for studies, but it identifies 3 major problems in these statistics. First, that the A and AR, the agreement rate, the agreement indices do not account for agreement by chance, and they do not reliably capture how participants agree on their mappings. Second, the interpretation guidelines given by Vatov and Walbrook may lead to wrong conclusions because they are based on some incorrect probabilistic reasoning. And third, they're both significant tests while huge type 1 errors, and they should not be used. So I will try to summarize these main points, starting with an example of a study on a paper phone which was published back in 2011. It's a very well-cited study. We try to identify bend gestures for bendable, flexible devices. So here the authors, actually there was 3 sessions in this study. I will talk about the 2 last sessions where agreement was actually quantified. So they used the A index, the first index, they found a value of 0.326, and for the second study, an agreement higher than that. Actually, if you see that and you compare it with previous studies in the literature, actually these are comparable or higher than many of the previous scores reported in previous studies, for example, by the study of Walbrook and colleagues on gestures for tabletops. Now, what is surprising is that the authors came up with this conclusion that the actual overall agreement was low. There was no actually, each participant has his own preference. So this is quite surprising. Some people may actually notice that actually in this study there were 10 only participants, and the A index inflates agreement. So let's see what if we use the AR index, which is improved index even for small samples. So we get smaller values, but again, these values are respectable based on the standards and the previous, if we compare with previous studies. And actually, according to Vatov and Goldbrook, this demonstrates median agreement. So what happened? Why the authors did not find any agreement? So let's go back to 1960, when Jacob Cohen introduced a coefficient for agreement, which is very well known and used in many, many disciplines, which is the Cohen's kappa, which measures agreement between two only raters. Since then, actually, have been a range of different agreement coefficients for many different assumptions. I will talk here about the Flays, a paper that appeared 11 years later, which introduced the Flays kappa, which measures agreement among multiple raters. 1 year earlier, it was Klaus Krippendorf, which introduced the alpha, which is actually widely used in content analysis. And Krippendorf's alpha is a very generic index that deals with multiple layers, incomplete data, and a range of different scales, nominal, ordering, and scale. So both for simple designs that we're interested here, there are more than 5 raters and no missing data. Both indices actually give very close results. Okay, so let's use these indices and go back to the study that we saw earlier and calculate Flays kappa, and we see that this is a very low value, right? It's close to 0. And we do the same for Krippendorf's alpha, and we get, again, very small values. Now, let's do something further and assess the uncertainty of these estimates, right? And what we're going to use some interval estimates, confidence intervals, using a technique that I will briefly mention later, the jackknife resampling techniques. And we see for Flays kappa that the confidence interval includes 0, which means actually, yes, there is no any statistical evidence that shows any agreement in this study. And the same is for Krippendorf's alpha. You also see that there are negative values here. The negative values in these measures may demonstrate disagreement or agreement below chance. Okay. So, yes, actually, the authors were right, but which is interesting here, they based this conclusion not on statistics, but based on common sense and intuition. So let's go back to some all other studies. So here it's a reanalysis of 4 gesture elicitation studies published at SIGCHI. And we see here all the different measures, and we see that there is a high discrepancy between AR, and the Flays kappa or Krippendorf's alpha, right? And for some studies, for example, here for the case of the metaphor keyboard of Bayes study, we see that there is a small difference between small discrepancy. But for other cases, the discrepancy becomes here for another part of their study. We have a larger difference. Or for the study here on the body location of the Onsky gestures, actually results are differences are quite radical. So what's going on and what's the reason of these high discrepancies? So this is actually a very generic formulation of most kappa statistics. This term here is called the percent agreement, and actually for Flays kappa it is identical to the agreement rate. Right, so this is the same now. Here, this is actually the term that makes the difference is a chance agreement that represents the probability that any two raters agree by chance. And actually, the influence of this term becomes higher the smaller the percent agreement is. So, why don't we use these measures in gesture elicitation while we use them actually in many other domains, even in HI for qualitative analysis? So Vatov and Goldbrook actually talk about this issue in the last paper, and they argue that these statistics are inappropriate because participants in gesture elicitation studies have to choose from an infinite number of gesture vocabulary. So in this case, the probability of chance agreement is 0. So it doesn't make any difference. So I will identify the paper, actually, the article, Tokai article discussing in-depth these issues, but I will here stay on two problems. The first problem is that sign vocabularies, what I argue here is that it can be particularly small. And one reason for that is that gesture descriptions, the proposals of participants are passed through a classification process done by humans, and the result of this process is signs. And many times the sign vocabulary can be particularly small. Second, There is often strong bias towards a very small number of signs. So what I call bias here is the overall tendency of some signs to appear more frequently than others, independently of the reference. So this is important, independently of the reference. Okay. So causes of that, I don't have time to talk much about that. There are, of course, usability and social constraints. There are gestures possibilities that are not usable, feasible, but there are also default signs, legacy, procedural, and classification biases. I'll just give an example for bias study on keyboard gestures for the sake of the default signs, how they can appear. For this study, actually participants produced a total of 27 unique signs. But one only sign, the top push gesture, account alone for 28 of all proposals. And actually, if you think about it, the reasons, this is the regular push, you push a button, right? This emerges when participants, we can suspect that participants, when we couldn't find a meaningful mapping, they pressed the top push button, right? So now I try to mathematically define the bias, describe the bias distribution by using two well-known distribution functions that account actually for an infinite number of signs. This is important. The first is the zip middle board distribution and discrete half normal probability distribution. Using this distribution, actually, we can assess the chance agreement. How? This is there are two Monte Carlo simulations running in parallel, where we assume that there are two anti-blindfolded participants. This means that participants cannot see which references are presented to them. They choose from an infinite number of signs, but under bias. Under the bias defined by these distributions. And you can see here, for example, that the agreement rate results in scores that are over 0, right here 0.2, while Flace kappa gives always values that are very close to 0, which is actually the behavior that we will like to have, would like to expect. Now, are these bias distribution realistic? I will say yes. So this is some examples from the 4 gesture elicitation studies that I presented earlier. And you can see here, for example, the example of the paper phone study that the bias distributions can lead to chance agreement that is over 20 or 25%. Now, recommendations first, report both raw percent agreement, the agreement rates, right, and chance correct agreements. Either Flace kappa, Kiberdorf's alpha, but probably other measures may be more appropriate depending on the design of the particular study. Now, also assess and visualize the observed bias distribution. So I will continue now with the second point, which is about how to interpret agreement. As we said, what level of agreement is high or sufficient for a gesture elicitation study. So in their first paper, Vatova and Gobrook proposed a probabilistic reasoning, and based on that, derived some thresholds about how to interpret agreements. For example, agreement values between 10 and 30% are interpreted as median agreement. Now, even if one disregards the problem of chance agreement that I mentioned earlier, chance agreement, actually, we can show that this probabilistic reasoning has several problems, and this can lead to many wrong conclusions, right? So I would say, so in their paper, actually, I also argue that there is no way based on probabilities or statistics to come up with such guidelines, even if one follows a different approach. Now, here actually I show several different guidelines by previous literature in reliability studies that have tried to interpret agreement, but for all of these cases, it is widely acknowledged that many of these thresholds are arbitrary or very domain-specific. Right. So actually here I cite the Kiberdorf, who says that the acceptable level of agreement below which data to be rejected as unreliable should be chosen depending on the cost of drawing valid conclusions. And I would say here that which are these costs and for gesture elicitation is not well understood yet, right? So this is actually a very interesting area for research work, for future work. Now, so recommendations number 2, avoid prescribed thresholds for the interpretation of agreement scores until we have more clear idea about what these thresholds could be. And I'm going to the last point now, which is about significant tests. I would say we need to probably find a way and make inference, statistical inference, understand whether there are some differences, whether there are differences between different agreement scores. And as I mentioned at the beginning, there are two statistical tests proposed in the literature, the VRD statistics for within participants comparison and the VB statistics for between participant comparisons. And again, here in the paper, I described why. So these statistics, these statistical tests are based on some probabilistic reasoning that has several problems. And as a result, it yields in type 1 errors that are larger than 40% for alpha levels of 5%. And I saw you here a simulation, Monte Carlo simulation that evaluates this error. Actually, for people who know a little bit about statistics, when we say alpha level 5%, when we actually reject the null hypothesis, when the p-value is smaller than 5%, so the reference here is 5%, and this is actually the level that you expect to get for a well-behaved significant test. As you see here, the errors are below 40 or sometimes 6%. And as you add more participants, as here I have 30 participants, the error rates become even larger. Okay. So the VB, for the VB statistics, again, we have similar behavior, so very high type 1 errors. And here, actually, just an example to see how these errors can lead to problematic conclusions. So here, Vatavu and Gobrook tried to reassess the data, reanalyze the data of Bailly, which included 9 males and 11 women, and assess whether there was an agreement between these participant groups. And actually, they did a per-referent analysis and showed that a significant test for 7 referents, and based on that, they conclude that women and men reach consensus over gesture in different ways. So what I do here is a kind of permutation test that applies the VB test on random partitions of the participants in the study of Bailly. And you can see, if we wait a little bit from this, that the number of statistical significant difference for random participants 806. You can have more, and you find a similar number. You can do more samples, and this is greater than the 7 significant differences found for women and men. So actually, there is not any evidence to support this claim. So remedies. Actually, finding a way, an analytical method to derive the sampling distribution of such statistics is very difficult, right? So, but fortunately, there are some resampling techniques, Monte Carlo techniques that can be used to construct interval estimate of agreement scores. So here I have jackknife resampling, that's a very old technique, and bootstrap resampling, which is a newer technique. And I saw in the article how we can use these techniques to support both within participants and between sub-participants to test for differences between and within participants. So recommendations number 3, report interval estimates for agreement scores and for their differences. Either using jackknife technique, this is what I tested in the article for individual score within participant differences, and the bootstrap for between participant differences. So just a very brief discussion. I don't have time to talk more, but I think that it's also important to think about what agreement values are about. And sometimes agreement values actually don't say nothing themselves. We don't know the reference of agreement, what participants agree upon. Right? So here you see a picture for the agreement, big agreement at the conference in Paris in 2015, where you see the leaders celebrating about their agreement, but I bet that very few people understood what this agreement was about. Right? So this is just to say that I feel that it's very also important to well specify the gesture classification process and verify its reliability because actually, I mentioned that because it's something that's missing in many several gesture elicitation studies. So I would really like to thank all the authors of the papers of the studies that share the data with me. Without their help, it wouldn't be possible to reanalyze the data. Actually, this is a single author article, but I would really like to mention the help of Pierre Dragicevich, who has actually even participated with our code and helped me a lot. The article actually has been partly based on our older short report that we wrote back in 2015. And this is the end of my talk. Actually, there are materials, our code for all the tests and many examples online. Don't hesitate to send me an email if you have questions or if you find errors and problems. Thanks.
As I mentioned, there's microphones at the front on either side of the auditorium for questions. Great work in cramming 50 pages into 15 minutes. There's a lot of material in there. So you've talked about some potential changes to how we run and analyze gesture elicitation studies. Given the amount of work in this space, and we've even seen some work presented on Monday, can you talk about the scale of impact of your work? How many papers might need to be reconsidered, or how many conclusions might need to be rethought?
So I guess, I don't have a clear idea, to be honest, about I think that, for example, many of the problems that I showed, for example, the effect of bias on the small sign, the vocabularies, actually doesn't affect, I have the kind of intuition that it doesn't affect equally all the different studies. So there are studies, for example, that where gestures are less symbolic and more direct manipulations that suffer less from this kind of problems. Now, I think for all the studies in general in HI research, we need more replications, right? And this is something that is missing not only for gesture elicitation, but globally. So I think it's very important. I would like to note here, make your data available because other people can get them and it's easier to analyze. So it's very important to share our data and try to, I don't have a kind of...
That's right. Mary.
Hi, Meredith Ringgold Morris from Microsoft Research. So I think I'm a little bit confused because the original elicitation method is not a particularly quantitative method. So I feel like the work you're presenting here is really getting into the minutia of statistics, but if you think about the original method, it's really in some sense a qualitative method, right? It's a method about a way to have a kind of participatory design and adding a more formal method to a qualitative process, right? How to gather the input from the users, a process for resolving different conflicts in the input. But the original method never claims that there's, for example, a single optimal grouping of the gestures, or that one set of experts versus a different set of experts may not parse what agreement semantically means slightly differently than each other. So in some sense, I feel like I guess I'm not totally sure what some of these things mean. So for example, like when you talk about the type 1 error, could you clarify what error are you referring to? Are you referring to an error in the way that one analyst groups gestures together?
No, this is
versus another?
No. This has nothing to do with that. Probably I will start with the last question and then go back to the first one. The type 1 error is, for example, imagine that we have. So this is about statistical tests, and all the statistical tests are supposed to be tested and have a specific, to be well behaved. So which means that if we imagine that there is a population here of people, of participants, and we randomly get 2 samples from this same population of participants, actually we don't expect to have any kind of difference because they are from the same population, right? It's a random sample for 2 different populations. So all the statistical tests, when we say that we have the bar on 5, because in all experimental work that we do in HI, most of the time we set the bar to the 5%. So if P is below
I understand what a type 1 error is.
So
I don't understand what's
the effect of
error that you're measuring specifically around this method.
So this is, the conclusion that I said, having women and men, and having the conclusion, that yes, agreement and women and men agree in different ways. This is a result of the high type 1 error of this particular significant test. So if this error is high, this means that all the conclusions are random. If it's 50% of the time, the test will show that there is a difference when there is no difference at all. So this is a big problem. This is a problem if conclusions are based on hypothesis testing, which is the case here.
I think my confusion stems from, again, maybe this is a semantic interpretation.
No, this is not a semantic. This is mathematically and statistically.
Could I finish my comment? Thank you. Of the word agreement itself. So I think So I understand that, you know, you're talking about other statistical metrics like kappa and things that represent a concept of agreement, but I think that that concept of agreement is semantically different than the concept of agreement that the original method proposes. So the original method isn't necessarily proposing that agreement metrics are a final statistical concept that one should be drawing statistical conclusions from, right? Rather, it's meant as a tool for helping the people performing, again, this rather qualitative method to understand their method, but no one's trying to claim in the original method that there's one right or wrong answer, or that one should be testing the quality. So I guess I'm not sure that it makes sense to compare those different kinds of agreements semantically. So I guess that would be my feedback, but I'd be happy to talk with you later. Thank you.
Okay.
All right,
I don't know.